Welcome to a new lesson, Introduction to Hive. Let us first start with the need and the advent of Hive. Hive was developed at Facebook with a similar reason to that of Pig. It was developed for data scientists with weak Java skills to give them ability to work on data in Hadoop. To help them, they designed Hive, which is an SQL-like language. So if you are familiar with SQL, you would find yourself at home with Hive. Although it suits data analysis very well, one of the major limitations with Hive is that machine learning algorithm cannot be designed in Hive. Hive is designed to perform operation on the data such as slicing and dicing and not to process the data with advanced logical operations. To do that, MapReduce with Java language is still the best fit. One more fundamental idea with Hive, which is in line with Hadoop ideology, is that the schema can be changed and is bound by the data at the time of read and not at the time of write. This core idea sets Hive apart from the traditional relational database systems where the data should comply with the schema at the time of write. In Hive, the compliance of data to schema is verified at the time when the query is issued. Let's look at the basic syntaxes and a few basic commands in Hive to get feel of Hive and how you can perform operations using Hive. First we see here is a create table command executed in an interactive shell. Like Pig, Hive can be written and executed in script mode, interactive mode, and embedded mode. Hive-e signifies that the command is run in the interactive mode. The command is create table, then the table name, records, followed by the column name and the data types, which is syntactically the same as we see in SQL. And then we perform the row format delimitation, which is a change from SQL. Here we specify comma as a delimitation, and any symbol can be explicitly be specified there. In Hive, delimitation information plays a vital role when the data is stored or read. At the time of creation of the table, the rules and information about the table is stored in the database, which is known as metastore. Metastore is a relational database which is used to store Hive's metadata, that is, information pertaining to the table. Popular choices for this relational database are Apache Derby and MySQL. At the time of creation of the table, there would be an entry specific to that would be put in that database. Then there is the load command, which loads the data into the table. Here we specify the input path. The keyword override specifies that the data should override if there was any data in the table before this. Then through the select command, we can perform analysis on the dataset. For example, in this case, select PRJ ID summing bill hours from records where PRJ ID is not equal to PRJ001 and group by PRJ ID would yield the total hours for all the projects except for PRJ001. So in this way, Hive can play an important role in preparation of the data, which eventually would be used by a MapReduce job. Let's look at a few important Hive concepts which would build a fundamental idea behind how things work in Hive. There are two ways in which table can be declared in Hive. First is the managed table and the other one is the external table. The managed table, as the name signifies, implies that the data file needs to be managed by Hive itself. With the command as shown, a managed table is created. It is the default way of creating a table. Now when we would perform the load action, the input data file would be moved from its original location in HDFS to a new location in HDFS, which is the warehouse of Hive. Hive would now manage the file completely at its warehouse. Hive warehouse is nothing but a specific directory in HDFS which is managed by Hive. So later when you do a drop command, Hive would delete the data from its warehouse and its related data from the metastore, and hence the complete file would cease to exist. However, there is an option to declare the table as an external table as well. In this declaration, you would see an additional external keyword that is used. Now when the same load command is executed, Hive only performs a link to the original dataset and doesn't even check if the data is there. It just makes a related data entry in the metastore. So it doesn't even check if the data is there at the location or if the data complies to the schema. This gives programmer ability to design a job which would put the data at the location just in the nick of time before Hive takes it for processing. This process of late binding of schema is termed as lazy in Hive, and it's a common jargon that would be used. So in this case, when the drop command is issued, only the entry in the metastore gets deleted and the data still remains there. So there are these two methods in which Hive tables can be declared. It can be either managed by Hive itself or it can be declared as an external table. Another interesting feature or a concept which Hive has is that data can be divided into partitions and buckets. At the time of creation of the table, you can choose to divide the table on a column of data. For example, if you can partition it by PRJ ID, at the time of the load, there would be files created for all different project IDs as shown. And so if you want to perform analysis on a certain range of values of that column, the operation would be performed in a quicker way. Hence, always it is a good idea to partition the column on which the data would be sliced the most often. Then there is another way of division of data which is known as bucketing. For that, syntax would be ending with the clustered by clause, specifying the column name on which the bucketing needs to be performed and the number of buckets of the data that needs to be divided into. Bucketing operation processes the specified column data in exactly the same manner as a partitioner treats keys. It first hashes the column and performs modular operations using the number of buckets to determine the bucket number corresponding to which there would be a file and the data would be put into that. In a huge dataset, this is a great help as it makes the data sampling easier. Another benefit of this is that if there are two datasets which have a similar column and we want to perform a join operation between them, then if we perform clustering with the same number of buckets on the same column on which the join needs to be done, the outputs would serve all the criterias for the map site join. And so this mechanism is sometimes used to prepare the dataset for the map site join. So many a times data would be processed with Hive and then a MapReduce job may run on it. For that, let us look how the data is getting stored when processed by Hive. There are two most important dimensions to be understood when the data is getting stored by Hive. First is the row format and second is the file format. Row format deals with how the data fields are stored in the Hive table, how the fields would be delimited, how the rows would be delimited, how keys and values would be delimited, and how collections, which is a complex object made of several data types, would be delimited. This is important when you're writing a MapReduce job which reads the data which is previously processed by Hive. A default explicit declaration of such a storage would be as shown. The terminology that is used to describe row format is SERD, which is a short form of serializable and deserializable. There are many types of SERDs which may store the data object as text or binary or column-based format or a regular expression and so on. Then coming to the file format. File format can be either stored in the form of sequence files or RC files. Row-oriented layout is known as sequence files, and if these are binary encoded, while designing the MapReduce job, we would be using sequence files. Another method is to store the column-oriented layout, which is known as record columnar file, in short RC files. The files stored in this format are stored as shown. This method of storage gives advantage only if a portion of columns are to be read repeatedly and others needs to be discarded. So all in all, you should be aware of the data format in which the data is stored in Hive before you write a MapReduce job which processes that data.